Hi everyone. Okay, so for today's lesson, we're actually going to be talking about scientific notation. Remember that you will be required to submit a picture of these notes, so you need to be writing them down as we go in your notebook and be prepared to send me an image at the end of this lesson. All right, so let's just start with the definition for scientific notation. It is a way to express very large or very small numbers. All right, so let's talk about the format for scientific notation. First, you have a number. This number has to be a decimal number it has to have one non-zero digit to the left of the decimal. So it has to have some kind of whole number in it. Okay, you're going to multiply. And I know that, in algebra, we practice other ways to write multiplication, but in scientific notation, you use the X that you kind of learned in the very beginning. You're going to have the number 10, and this 10 is going to have an exponent. So let's just kind of go back through these pieces one more time. Okay, so in that first number, it's a number with exactly one non-zero digit to the left of the decimal. So basically, I'm going to lay out all the possibilities. You can have 1 point something or negative 1 point something. You can have 2 or negative 2, 3 or negative 3. And you can have other numbers after the decimal point. The important part is what's in front of the decimal. It can be 1 or negative 1, 2 or negative 2, 3 or negative 3, 4 or negative 4, 5 or negative 5, 6 or negative 6. Again, you can have other numbers after the decimal, but in front of the decimal can only be these options. 7 or negative 7, 8 or negative 8, and 9 point something or negative 9. You cannot have any other number in this position aside from the ones that I've shown you below, from 1 to 9. That's it. Everything else is considered not correct format. So you could never have 10 point something as that first number. It can only have it has to have one number in front of the decimal. It has to have one number in front of the decimal. Okay, so then here in the center, you already know that this means to multiply. You already saw that this has to be a power of 10. And then the exponent is important because it tells us how many times the decimal moves. If the exponent is negative, we'll move the decimal to the left. And a positive exponent will move the decimal right. Okay, so negative moves the decimal left, positive moves the decimal right. All right, so now that we've kind of looked at all of the different pieces for scientific notation, let's kind of look at some examples on what we would do here. Okay, so here's our first example. This is a good example of scientific notation because, again, I have 1 point something, and we said on the previous slide that there has to be only one number in front of the decimal. You have your multiplication sign, you have your 10, and you have your exponent. So those are all the pieces that you should see when you have a scientific notation problem. So now the exponent is the most important part of this because it's going to tell us what direction to move the decimal. Since the exponent is negative, I'm going to literally take my decimal and I'm going to move it left 5 times. So I'm going to jump over the 1, 2, 3, 4, 5. And I want you to think about this like an egg carton, like a carton of eggs. We're going to add in zeros to fill in our egg carton. So my standard form would be what happens when I change this number. I have the decimal point, then you see those zeros that I wrote in blue? I have those 4 zeros, and then I have a 1, a 2, and a 4. And what happens when you change it over is that the 10 and the the 10 and the exponent and the multiplication sign all go away. All right, and so standard form is just the regular decimal. Scientific form is us showing it with multiplication. All right, so let's try another example. Okay, so here we have 6.5, and we have a positive exponent this time. So that means that instead of moving the decimal to the left, this time I'm going to move the decimal to the right. So I'm going to write out this 6.5 again, just to help me show my work. And then I'm going to take this decimal and I'm going to jump over 4 numbers. Ready? 1, 2, 3, 4. And now you can see that egg carton being built, and we need to put eggs in the carton. So there's a 0 right here, 0, and a 0. So this number is actually equal to, I'm just going to kind of put an arrow here so you see how they match up. In standard form, it would be 6, 5, and then those 3 zeros that we wrote down in blue. So really, this whole topic is about moving the decimal and understanding which way the decimal moves. Okay, let's try another example this time. Okay, so here is another example. This time we have a negative number, but remember I said as long as it kind of only has one number in front of the decimal, it's fine. If it doesn't matter if it's positive or negative. And it actually doesn't change what we do either, because the most important part of this problem is the exponent. And the exponent is negative. It's -2, which means that I need to take my decimal and I need to move it 2 times to the left. So if this is kind of confusing for you, or you're not sure which direction to move the decimal, negative exponents mean that you have a very, very small number. And positive exponents mean that you have a very, very big number. So again, I'm going to fill in the egg basket. Don't forget about that negative sign. I know I kind of wrote over it. So let's write this in standard form. I have negative, decimal, that blue 0, the 5, the 7, and the 3, and the multiplication sign, the 10, the -2, all kind of goes away when I put it in standard form. Okay, so in these examples, instead of actually having the number in scientific form, we're going to start with numbers in standard form. So let's do negative. Okay, so here we have our problem. Now first, let's figure out where the decimal has to go. The decimal cannot go there, because if I put the decimal here, my number in front is a 0. And remember, we said the number in front can only be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So that's the only thing that we can have in front of the decimal. So I'm going to put my decimal here so that the number in front is a 5, a single digit number in front. What comes after doesn't matter. And now I'm going to count how many spaces does it take me to get from my new decimal to my old decimal. 1, 2, 3, 4. It took me 4 jumps to get to my new decimal. So now let's write this in scientific notation. Negative 5.93, that's where my new decimal is. I'm going to multiply by 10, and then it took me 4 times to get to the original decimal, and this is a very small number. It's a very small decimal. So that means that my exponent is negative. Remember, small numbers have negative exponents. Large numbers have positive exponents. Okay, let's do a few more examples. Okay, here we go. We have a very large positive number. I mean, I guess I could throw in all of these commas that we have in there, or not. So remember that on a whole number, if we don't see the decimal, it's because the decimal is at the back of the number. So that's going to be something really important. If you don't have the decimal already in the number, it's at the very back of the number. Okay, so we need to be able to move this decimal. Now we cannot move the decimal right here, because if I move the decimal here, in front of the decimal is the number 73. That's not on our list of possibilities. We said in front of the decimal can only be numbers 1 through 9 and nothing else. So from our old decimal to where we're going to put the new decimal has to be right here, so that in front of it is a 7, and 7 is between 1 and 9, so that's okay. And now we're going to count from our new decimal to our old decimal. 1, 2, 3. Notice how I'm making that egg carton again, and I'm making sure there's a number in every little pocket of my egg carton, and I lost count. 1, 2, 3, 4, 5, 6, 7. This moved 7 different times. So my number in front is 7.37. Notice how all of the zeros got taken away. I'm going to multiply by 10, and we said we moved it 7 times. And since this is, since this is a very large number, my exponent is positive. So positive 7. Okay, a couple more examples. I'm going to go a little bit faster through these examples. So here's my decimal point. My new decimal point has to be here where the number in front is an 8. And I'm moving the decimal 1, 2, 3, 4, 5, 6, 7, 8 different times. So I'm going to write 8.019. All those zeros go away, times 10 to the positive 8. Okay, let's try this again with the smaller decimal number. Okay, I have the decimal 12 thousandths. Here is my original decimal. My new decimal has to be here so that the number in front is only a 1. And I'm going to move it 2 times. I'm going to write 1.2 times 10. And since this started out as a very small decimal, that means that my exponent is negative, and I'm going to write -2. So we did several different examples on between scientific notation and standard form. You do need to know how to go both directions. If you need help, make sure that you're logging into your Zoom calls. And again, you need to have a picture of the notes and these examples uploaded onto this assignment in order to get credit for this. All right, thanks. Have a good day.